Hi guys, welcome back to Derive. Today we're going to review the techniques of integration from Calculus 1. Okay, so we're going to start out by reviewing some of the techniques of integration that you learned in Calculus 1. So this is going to be a review. All right, so we're going to review the Calc 1 integration. So we're going to start out, we're going to evaluate each integral. All right, so actually I'm going to let you guys try that. So I'm going to give you maybe about 20 seconds to give that one a try. See if you can work that. All right, did anybody get an answer for this one?
Yeah,
Can you tell me what your answer is?
2x to the fourth plus x cubed plus c.
You guys agree with that one? So how could we tell if this is right, the right answer?
Take the derivative.
Take the derivative.
And what should I get when I take the derivative of it? This guy, right? The 8x cubed plus 3x squared. So we can see that it's correct by differentiation. All right, so let's try another one. Okay, so how can we work this one?
U-sub?
Not a u-sub. Is there any way I could somehow get this to be like powers of x so I could do it like the one I just did?
Yeah.
So how can I do that?
X to the 1/3.
Yeah, I can write this as x to the 1/3. So this is the same thing as x to the 1/3 and then x minus 1 dx. And then what can I do from there?
Distribute.
We're going to distribute. So when I distribute, what am I going to get?
X to the 4/3 minus x to the 1/3.
X to the 4/3 minus x to the 1/3. Good. So we're just multiplying it by both of those guys. And so when we use the power rule, remember we're going to add 1. So I'm going to have x to what power when I add 1? 1 is 3 over 3, right? So I'm going to have x to the power of
7 over 3.
7 over 3 times what?
3 over 7.
Times 3 over 7 minus, when I add 1, I'm going to get x to the 1/3 plus 3/3. 4/3. So we have 4/3 and then times 3/4. And then we're going to add c. All right, so let's say we have let's say we have that one. So what's the technique that we're going to use for this one?
u-sub.
U-sub. So u is going to be what? What do I pick for the u?
Root x.
The root x. And so what's my differential? What's my du going to be?
1 over root x dx.
1 over 2 root x, right? Because you're going to have, this is x to the 1/2. So I'm going to have 1/2 times x to the minus 1/2, which is this guy. Now, I don't have that, right? I don't have 1 over 2 root x dx. I just have 1 over root x. So what do I need to do to both sides of this equation so I can sub it?
Multiply by 2.
Times by 2, good. So I'm going to have 2 du is equal to 1 over root x dx. So when I sub that in, this is going to give me sine u, and then times 2 du. And then remember that a property of integrals is that you can pull the constant out in front. So this is equal to 2. And then you need to remember what function has derivative sine u? What's the antiderivative of sine?
E minus cosine.
Minus cosine, good. So this is going to be equal to minus 2 cosine of u plus c. And then the last thing you're going to do is put back in for the u. So you're going to have minus 2 cosine of root x plus c. And that's it. And then again, if you wanted to double check, you could differentiate that and you'd see that you'd get the integrand there. All right, so we have this one. So this is another u sub. What's the u going to be?
X to the 4th.
All right. Why don't you guys try it from there? See if you can work it the rest of the way. I'm going to give you a little bit of time to try and work that. Did anybody get 1/4 times e to the power of x to the 4th plus c?
Yes.
Yeah.
Okay, great. So the du in this case is 4x to the 3rd dx. Now we only have x to the 3rd dx, so we need to divide through by 4. So I'm going to have 1/4 du is equal to x cubed dx. So when I sub in, I'm going to have an e to the u and then times 1/4 du. So my antiderivative is going to be 1/4 e to the u plus c. And that's going to be 1/4 e times x to the 4th plus c. Okay, how about this one?
U is ln of x.
And if u is ln of x, then what's the du going to be?
1 over x dx.
Great. So after I sub, what do I have?
Cosine of u.
Cosine of u.
Du.
Du. And so what's the antiderivative?
Sine of u.
Sine of u.
Plus c.
And putting it back in terms of x.
Sine of ln of x.
Good.
Plus C.
Plus c. All right, you guys are doing good. Let's try another one. How about that one?
Could you make u x squared?
Yeah, good. Because we can think of this as being x squared squared, right? So if we let u equal x squared, then the du is going to be equal to what? Just the 2x, right? So we got 2x dx. And so 1/2 the du is equal to x dx. So after I do the sub, what do I have?
One over
You
the
have
square.
1 over root u du.
No,
Correct.
1 minus u
1 minus.
squared.
1 minus u squared inside the root.
Yeah.
And then I also have this 1/2 here, right? So I can pull out the 1/2. And so I'm going to have 1/2 Does anybody remember this one? It's one of those inverse trig ones.
Sine.
It's the arc what?
Arcs.
Sine. Sine.
Arc sine. So this is going to be equal to 1/2 the sine inverse of u. And then we can just go ahead and put back in for the u. Questions on that? Let's keep on doing a few more of these. How about Okay, so how about this one? So what's the u going to be?
One plus secant theta.
1 plus secant theta.
Okay, so let's try that. So u is equal to 1 plus secant theta. You guys remember the derivative of secant?
Secant tangent.
Secant tangent, good. So the du is going to be equal to secant theta, tan theta, d theta. So that's going to take out all of that. So what are we going to be left with after we do our sub?
1 over u.
1 over u, good. And
The natural log of u.
so we're going to have our natural log. So we're going to get the ln of the absolute value of u plus c, and then we can just put in the 1 plus secant. Let's try one more. All right, so we have this one. Now this is a little bit trickier than it looks because we would like to get powers of x here, but the problem is that we have two things under the radical instead of just one. So we have to make kind of a different type of a u substitution. So can anybody think of a substitution that we would make so that we get only one thing under the radical?
I think we can do u x equals 1.
U
And
equals
then
what?
get u equals x minus 1. And
X
then get
minus
the
what?
x in terms of x minus 1.
Yeah, so
You
what's
get
the
it.
du going to be then?
dx.
Yeah.
And then we can get the x in terms of u.
What is x in terms of u?
It's u plus 1.
U plus 1, good. So this means that the x is going to be equal to u plus 1 by just adding 1 to both sides. And so then we're going to have u plus 1 times root u. And now what do we do?
Distribute.
Distribute. So remember, this is the same thing as u to the 1/2. So what am I going to get in terms of powers of u?
U to the 3/2 plus u to the 1/2.
So we're going to get u to the 3/2 plus u to the 1/2. And then I can just do my power rule, right? So when I do my power
Yeah.
rule, what will I get?
U to the 5/2 over 5/2.
So I'm going to have
So
u to the 5/2 over 5/2, which is times 2/5. And then what about for this guy?
yeah, u to the 3/2.
Over 3/2, which is times 2/3. And then the last thing I'm going to do is just put back in for the u with the x minus 1. So I'm going to have 2/5 x minus 1 to the 5 over 2 plus 2/3 x minus 1 to the 3 over 2 plus c. All right, so let's try one more. So everybody look at that for a minute and see if you can think of what your sub is going to be.
I think we should put natural log of e to the x plus 1.
Okay, so if I let u equal the log of e to the x plus 1, then what's my du going to be?
1 over e to the x plus 1 times e to the x dx.
Yeah, so you're going to get 1 over u times the derivative of the inside, which is e to the x, times dx. And so what am I going to be left with after I make the substitution?
This is du over u.
Just du over u. So I'm just going to have 1 over u du. And so this is going to be equal to the ln of e to the x plus 1 plus c. And I can actually drop this absolute value because the ln on the inside is going to be non-negative. And so I can just write this as the ln of e to the x plus 1 plus c. All right, so we've been looking at some indefinite integrals. Let's take a look at some definite integrals now. So we're going to evaluate each definite integral. All right, so can anybody think of an antiderivative for 1 over x squared plus 1?
Arctangent.
Arctangent. You guys are awesome. And so then we can just evaluate it. This is a definite integral. So we're going to do a subtraction here. So this is going to be equal to the tangent inverse of 1 minus the tangent inverse of 0. What's the tangent inverse of 1?
Pi over 4.
Pi over 4. And tangent inverse of 0?
Yeah.
0. So we're going to get pi over 4 minus 0, which is pi over 4. All right, that's great. Let's try how about this one?
You would use u sub
Okay, so what's the u going to be?
1 plus tangent t.
1 plus tangent t, good. And what's the differential going to be?
Secant squared t dt.
Secant squared 3 dt.
Okay, good. Now, since this is a definite integral, what we're going to do is we're going to change the limits of integration. So we're going to end up with u squared. And then this part is just the du. And here we have u squared. So if t is equal to 0, what's u? So when t is 0, these are the t limits. So when t is 0, what's u going to be?
1.
1,
And then when t is pi over 4,
2.
2. All right, so then we can just integrate this now. So we're going to have 1/3 u cubed from 1 to 2. And this is going to give me 1/3 of 8 minus 1, which is 7/3. All right, let's try this guy. All right, so this is another u sub. What's the u?
1 plus 1 over x.
1 plus 1 over x. And you can think of that because that's the inside of a composite. And then the du is going to be pretty close to that. So what's the du going to be for this one?
Minus 1 over 2x.
Minus 1 over x to the,
1/2.
not 1/2,
Squared.
squared. And so I don't have the minus here, so I have to multiply both sides by a minus. So I'm going to have minus du is equal to 1 over x squared dx. And so this is going to give me minus, and then I'm going to have the root of u. And let's go ahead and change the limits of integration. So if x is equal to 1, what would the u be?
2.
2. And then if x is equal to 4, what's u? So you have 1 plus 1/4. So 1 plus 1/4 would be 5/4. And remember that we can switch the order of integration by just using this minus. So this is going to be equal to the integral from 5/4 to 2, and then u to the 1/2. And so using the power rule, we're going to get what? U to what power?
3 over 2.
3 over 2 times 2/3. And then we're going to go from 5 over 4 to 2.
2.
And so remember that there's a rule that when you have x to the 3 over 2, that's the same thing as x root x. So just keep that in mind. So this is going to be equal to 2/3. And then I'm going to have 2 root 2 minus, when I put in the 5 in here, I'm going to have 5 root 5 over 8. And so I'm going to go ahead and see if I can simplify this so I can get a common denominator. So we're going to have 2/3, and it'll have 16 root 2 minus 5 root 5 all over 8. And I can reduce. So I'm going to have 16 root 2 minus 5 root 5, whoops, all over 12. Questions on that one? All right, let's try just a couple more here. Okay, so we have this one. So what is the u going to be?
Natural log of x.
So let u equal the ln of x. And then the du is going to be what? You guys remember that one?
One over x.
1 over x. So my integral is just going to end up being 1 over root u. And let's change the limits of integration. So when x is e, what's u? What's ln of e?
Just 1, right?
1.
Just x.
And then what are we going to get when x is e to the 4th?
4.
4. Now, you guys may remember that the derivative of the square root of x is 1 over 2 root x. So one way to do this one, other than the power rules, we could just write like this. Because this 2 and the 1/2, they would cancel out. And so this is just going to be equal to 2 times root u from 1 to 4, which is going to give me 2 root 4 minus 2 root 1. And so that's going to give me 2 times 2 is 4 minus 2, which is 2. Now, what if I have the integral from 0 to 2 pi of the absolute value of sine x? So I have that. So how can I do that one? Because I have that absolute value. That's kind of tricky, right? So if you remember,
You separate them into 2 different parts.
yeah, because remember that the sign changes sign at pi. And so we're going to have, this is going to be pi, and here we're going to have 2 pi. So this is y equals sine x. And so where the quantity in absolute value is negative, that means that we're going to have to flip it up. We're going to have to go like this. And so we can write this as the integral from 0 to pi of sine x,
X.
because in between 0 and pi it's positive. But what are we going to put between pi and 2 pi? What are we going to be
Negative
integrating?
sine x.
What is it?
Negative sine x.
Negative sine x, good. Now, even though I didn't draw it perfectly, I think you can probably tell that the areas are going to be the same by the symmetry. So both of these should give me the same quantity. So the antiderivative of sine is going to be minus cosine from 0 to pi. And the antiderivative of minus sine is what?
Cosine, positive.
Yeah, so this is going to give me -1. And then I'm going to have cosine of pi minus cosine of 0. And then here I'm going to have cosine of 2 pi minus cosine of pi. And so this is going to give me -1 times -1 minus 1. And this is plus 1 minus a minus 1. So this is going to give me 2 plus 2 equals 4. Questions on that one? All right, let's try one more. So do you guys know, is cosine an even function?
Yeah.
So since it's an even function, we can just go from 0 to pi over 2
and then multiply by 2.
and then multiply by 2. Because if we look at the graph of cosine, oh man, that's a really crummy drawing. Sorry about that. Let me try and do a little bit better. That's a little bit better there. So here we have just a piece of cosine. And this is pi over 2, and then here's minus pi over 2. So we're basically calculating this total area here. And you can see we can just go from 0 to pi over 2 and then just double it. And so we're going to have 2, what's the antiderivative of cosine?
Sine.
Sine. And from 0 to pi over 2. And so this is going to be equal to 2 times the sine of pi over 2 minus sine of 0, which is 0. So we're going to have 2 times 1 minus 0 equal to 2. Let's just try one more. All right, does anybody know how to do this one? It looks pretty hard, right? But is this function even or odd?
X cubed is odd.
It's even.
The tangent to the fourth is even, but what about x cubed times tangent to the fourth?
So it's going to be odd.
Odd. So what's the answer?
0.
Is 0. So whenever you have like an integral from minus a to a of odd, it's always going to be equal to 0. And so this is equal to 0. Now it's a good thing that that's equal, we got that that's equal to 0, because trying to find an antiderivative for that's going to be pretty crazy. But because it's an odd function and we're going from minus a to a, we can see that it's going to be 0. All right, so I'm going to start in with integration by parts. So here we're starting with the Calc2 techniques. So this is section 7.1. We won't get through this whole thing today, but we'll get started on it today. So this is called integration by parts. All right, so let's suppose there's a formula that we use when we're doing integration by parts. So I'm going to derive the integration by parts formula for you right now. So we're going to suppose u of x and v of x are differentiable functions. Then would the product of u and v be differentiable also?
Yes.
By the product rule, right? So then by the product rule, the ddx of u of x times v of x is going to be equal to u prime of x times v of x plus u of x times v prime of x. And so now we can integrate both sides. So we're going to get and then this is going to be equal to v of x times u prime of x dx plus the integral of u of x and then v prime of x dx. Now, when we integrate a derivative, they cancel the result of each other. So the left-hand side is going to be u of x times v of x, and I'm just going to write that as u times v. And on the right-hand side, this is the integral of v. This part here is, what's that equal to? U prime of x times d of x. Can anybody tell me what that is? That would be du, right? So this is v du. And then here, what's v prime of x dx?
dv.
dv, good. So what we're going to have is we'll have the integral of v du plus the integral of u dv. And so let's subtract this guy from both sides. So if we minus the integral of v du from both sides, we're going to have u times v minus the integral of v du is equal to the integral of u dv. And let's transpose the sides because that's usually how you do it. So we have the integration by parts formula. And the integration by parts formula is going to be that the integral of u dv is equal to u times v minus the integral of v du. And so, well, the question is, well, how could this formula be helpful to you? Well, we're going to be starting with this expression on the left-hand side. And so from here, we need to be able to get the right-hand side. So we're going to pick part to be u. And we're going to pick dv, because that's what we're starting with over here. And we want to be able to get to this formula on the right-hand side. Well, in order to write this formula on the right-hand side, I need to be able to find u and v and du. Well, I've already got u, and I'm going to have dv. So if I have dv, how can I find v? Well, if I have dv and I want v, I need to integrate. So we're going to integrate. To find v. And if I have u and I need du, what do I need to do with this one?
Derive.
Just derive derivative.
Take the derivative. So I'm going to differentiate. Differentiate to get du. So once I do that, at least I can write this down. So now I'm going to have u and v and du, so I can write this side. Well, how does that help me? Well, the way it can help you is that this part, the u times v, has already been integrated because we don't have an integral sign on this part. So if I can complete this integral by integrating by evaluating the integral of v du, if I know how to do that, then I will have completely integrated the integral of u dv. So it's possible that, you know, this part is already integrated and maybe this part is easier to integrate than the part that we had originally. So by doing this last piece, the integral of v du, by evaluating that, then I can complete the integration. So what we're going to do when we're evaluating it, we're going to pick part to be u, and that part we differentiate to get du. And we're going to pick another part to be dv, and that part we integrate to find v. And hopefully we'll get some practice at picking it in such a way that this one is something that we know how to do, and so that we can complete the integration. And that just comes from practice. All right, so let's start by doing a few of these ones. So we're going to evaluate the integral of x times sine x. Now, I know we did u substitutions before, but keep in mind that when you're doing an integration by parts, the u is different than when we were doing the u substitution, where we were generally letting the u be the inside part of a composite. So this u has a different process to it. So let's start out, let's put this over here. So we have x sine x dx. So we have to pick u to be something and then dv to be something. So I'm going to pick u to be equal to x. And then if I pick u to be x, then the dv has to be what's left. So the dv has to be everything else. So that's going to be equal to sine of x dx. Now, whatever I pick u to be, that I differentiate. So I'm going to get the du. The derivative of x is 1. So this is just going to be 1 times the dx. And then I'm going to integrate to get v. So what's the antiderivative of sine?
Negative cosine.
Negative cosine. Now, when you're doing integration by parts here, you don't need to put the arbitrary constant. You just leave it like that. All right, so now let's use the integration by parts formula. So then this is going to be equal to u times v minus the integral of v du. If you say it a bunch of times, it'll help you to remember it. So the integral of u dv is equal to u times v minus the integral of v du. U times v minus the integral of v du. Can you guys say it with me? U times v minus the integral of v du. Oh man, I didn't hear anybody.
U times v
Times v
minus the integral of v
minus the integral of
times
v
du.
du.
Come on, guys, all together now.
Okay, u
U
times
times
v
v
Times
minus.
minus
the
integral of v
du.
times du.
All right, so we sound like an orchestra, a little out of tune, but I think you guys are getting it. Okay, so let's put it in. So u times v is going to be, what's u times v going to be?
Cosine x.
So we have
Go back.
minus
Minus?
x.
Negative
Minus
cosine
x
x squared.
cosine x.
So I thought I
Minus
heard
x
minus x
cosine
cosine x. Did I get that right?
Yeah.
And then this is going to be minus the integral of v du. So it's going to be a minus cosine x. And then du is just 1 times dx. And so this is a double negative. So what I have is I have minus x cosine x and then plus the integral of cosine x. So notice by picking the u to be x, we reduce the power when we use integration by parts formula. So the thing that I have left to complete the integration is simpler than what I had to begin with. So that I achieved my objective. So what's the antiderivative of cosine?
Sine.
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 Sine x.
So I'm going to have minus x cosine x plus sine x and then plus c. Now, let's go take a look at the same problem. And let's say we picked it the other way. So instead of picking u to be x, let's say we pick u to be sine x. And then if we do that, then what does dv have to be? What's left for dv?
X.
Just x dx?
Yeah.
So then what's the v going to be? What do I get when I integrate x?
X squared over 2.
Yeah, I'm going to have 1/2 x squared. And then what's the du going to be?
Cosine of x.
Cosine x. So let's put this into the integration by parts formula. So this is going to be equal to u times v minus the integral of v du. So we're going to have u times v. So we have 1/2 x squared sine x minus the integral of 1/2 x squared times cosine x dx. Ugh. So what just happened there? Did I make things better or did I make things worse?
Worse.
Worse.
Yeah,
That's
I
bad.
mean, x times sine of x was bad enough. Now I have 1/2 x squared times cosine x. It's almost like that x cubed times cotangent to the fourth that we looked at earlier. It's getting worse. So in this case, by picking u to be the power of x, we reduce the power because we're differentiating, which means that you lower the power of x. And then the dv is the trig function. That's just the other another trig function that we get when we integrate it. But by picking the dv to be equal to x, that's a bad choice because then when you integrate, the power gets higher, and then we have an even harder problem to do than the one we started with to complete the mission there. So this is like not a good pick. And so after a while, you'll get in the habit of kind of figuring out like how to pick things to make a good choice. Let's do a few more. All right, so we have the log of x. So when you have a log, that's kind of going to be a giveaway once you've done a lot of integration problems that it's likely going to be an integration by parts problem. And so does anybody know how to differentiate ln of x? Anybody know the derivative of ln of x?
1 over x.
Does anybody know the antiderivative, the integral of ln x? Probably not. And so remember, when we're picking u has to be something that we can differentiate, and then dv has to be something we can integrate. So since we don't really know how to integrate ln of x, we do know how to differentiate it. Just by necessity, I'm going to pick u equal to the ln of x. Because other than that, I'm not going to know how to do this problem. And then what's left for the dv if we do that?
Yeah.
1.
Yeah, just 1 dx. And so the du is going to be equal to what?
1 over x.
So we're going to have 1 over x dx. And then what's the v going to be equal to?
One.
X.
Just x. All right, so now let's use the integration by parts formula. So this is going to be equal to, this is going to be equal to u times v. So we're going to have x, ln of x, and then minus the integral of x times 1 over x dx. And so if you take the x and multiply it by 1 over x, what does that give you?
1. Just the
One.
dx.
So just, yeah, so we have x, ln of x, minus the integral of 1 dx. And so what's the antiderivative of 1?
X.
X. So we have x, ln of x, minus x plus c. So now you do know the antiderivative for ln of x, but most people would use integration by parts to find that. Okay, so we're integrating the arctangent here. So does anybody know the antiderivative of the arctangent? Probably not. Does anybody know the derivative of the arctangent?
1 over 1 plus x squared.
Yeah, so just kind of out of necessity, we're going to let u equal the tangent inverse of x, because that's the one we know how to do. We can't let dv equal the tangent inverse of x because we don't know that one. And so what's left for the dv then?
dx.
Just got to be just 1 dx. And so the differential, the du is what?
1 over 1 plus x squared.
1 over 1 plus x squared, and then the dx, and the v is equal to
X dx.
x. All right, so then the integral of the tangent inverse of x. So we're going to have u times v minus the integral of v du. So we're going to get x tangent inverse of x, and then minus the integral of v du is going to be x over 1 plus x squared.
Yeah.
Now, this is one where we could do a u sub, but it's one that probably it's maybe more trouble than it's worth to do a u sub. So what if I put a 2 there? Could anybody tell me the antiderivative of this one if I put a 2 there? It's just going to be a log, right?
Yeah, it's natural log of 1 plus x squared.
But if I put the 2 there, what do I have to put in front of the integral to cancel that off?
Half.
1/2. So see, by doing something like that, I don't really need to do u sub. So then what I'm going to get is I'm going to have x and then tangent inverse of x and minus 1/2 the ln of 1 plus x squared. Let's see. Now I don't need an absolute value here because the 1 plus x squared is always positive. And so in these two examples, we saw that we're using integration by parts, and we're picking u to be equal to the thing that we know how to differentiate. So sometimes it's just the necessity that tells you how you're gonna pick it. Let's try one more. So here we're going to evaluate the integral of x squared e to the x. And so with this one, what we're going to try and do is we're going to try and reduce the power on this x squared. So if I want to reduce the power on the x squared, then I'm going to pick u equal to what?
X squared.
X squared, because differentiating is going to reduce that power, and then the dv has to be what's left. So v is equal to e to the x, and then the du is going to be equal to 2x dx. All right, so then my integrals, so I'm going to have u times v. I'm going to have x squared, e to the x, and then we're going to have minus the integral of v du. And so I can pull out the 2, and I'm just going to have x e to the x after I pull the 2 out of the integral. And then I have one more step. I'm going to have to do integration by parts again. So in this case, I have to do it a second time. So when I do it a second time, what's my u going to be this time? Just focus on this piece.
X.
So u is x. And then the dv is equal to e to the x dx. So we're going to get the du is equal to dx, and v is equal to e to the x. All right, so we're going to keep this first part the same. So we're going to have x squared, e to the x, and minus 2. And then for this part, we're going to do the u times v minus the integral of v du thing again. So we're going to have u times v. So that's going to be x, e to the x, and minus the integral of v du is just that. And of course, the antiderivative of e to the x is e to the x. So we're going to have x squared, e to the x, and then minus 2x e to the x, and then plus 2 e to the x plus c. All right, so we're going to do some more review of integration by parts next time. And we're going to go on to also look at integration by parts where we look at definite integrals next time.